చూడు ఒకసారి ఎట్లా Good evening, Santosh sir.
Hello, madam. Good evening.
Good evening, sir. Just a few minutes, sir. We for 3 minutes, and then we start the session.
Okay, madam. Okay, no problem.
Chaitanya, sir.
Yes, ma'am.
So, shall we start?
Yes, ma'am. Please start.
Okay. So, good evening, everyone. Today we have with today's expert with us, Dr. Santosh Kumar Verma, sir. Sir has completed his master's degree in 2006 and PhD in 2011 from School of Studies in Chemistry. Sir served as assistant professor at SSITM Bhilai from 2011 to 2014. He has completed postdoctoral research at Wuhan University of Technology from 2014 to 2018 and worked as a contract faculty at NIT Jamshedpur from 2018. He is currently working as associate professor at Yulin University, China. His research focuses on micellar enzymology and catalysis, nanomaterial synthesis for solar cell applications, drug discovery, natural antibiotics synthesis, and more recently, he is working on hydrogen energy materials for production, storage, and transportation. Sir has recipient of the Yulin City High Talent Science and Technology Research Project in the duration of span 2024 to 2026. Dr. Verma has published 65 research papers, among which 61 research papers are of SCI index, and he holds 10 patents across German utility grants, South African utility patents, Indian patents, and Indian design patents also. He has also contributed various book chapters and served as an active reviewer for leading international journal. Now I request sir to kindly proceed with his today's session on chemical engineering for a green and sustainable future. Over to you, sir. Thank you.
Hello. Hello. Good evening, everyone.
Yes, sir.
Yeah,
Good evening, sir.
Yes, am I audible?
Yes, sir, you are.
Okay. Here is my student Saraswati. Please help me to share the screen. Actually, in China, the Google
Yes, sir. I
platform is
already
not
shared,
working.
sir.
Yes, Google platform is not working, so I am taking help from my student, and she will help me to
Oh,
operate the slides. So,
okay, sir, no problem. The screen
okay,
is
madam.
visible, sir.
Okay, madam. Thank you. So let's begin the program. Good evening, everyone. I am Dr. Santosh Verma, now recently working in the Yulin University of China. Today, I am going to discuss about the chemical engineering for green and sustainable futures. And this is my first FDP program as well. So I am very thankful in beginning into Susma, madam, so giving me such an opportunity. And recently I am working in the hydrogen energy. So today I will discuss about the hydrogen energy. So we all know that uh, fossil fuel fossil fuels are very limited, and almost energy nowadays is producing from the fossil fuels and nuclear energy. So however, these energy resources are very limited, and we need to, which can be last in severe years, and we have to face maybe some severe energy or environmental issues. So to overcome such kind of energy problem in future, we need to develop some renewable and clean energy resources. For the same, there are various renewable energy sources nowadays scientists are working, such as photovoltaics, solar cells. So we can harvest the solar energy in the form of with the help of photovoltaic technologies. Second is about the fuel cell technology. So we can produce the hydrogen and generate the power using with the help of the fuel cell, and this is the very uh, warm research nowadays going on in the scientist lab. Third one is the, you can see this is the area is specific where the wind speed is more than 15 kilometers per hour. Then you can set around that kind of wind energy. So this is area specific. Now, we cannot do in all areas, but for the hydrogen energy, you can do anywhere. It is very convenient as well. So, okay, next slide. Hello, Saraswati, are you here?
Yes, sir. Yes, sir.
Yeah, next slide, please. Yeah,
So this one,
yeah, next one. Yeah,
this one, sir.
I cannot. No, I cannot see in my. Okay, sorry for technical interruption.
Sir, at our end, we are visible, able to see the slides.
Okay, so I can continue with the second slide. Oh yeah, yeah, I can see also. Now is moving. Maybe there is a network issues. You just go through the second slide. Second slide is about the commonly used hydrogen storage and transportation method. Is it clear? Yes, this one. Okay, here you can see, we can see the produced hydrogen can be produced with various sources or various method. We will discuss one by one. So the produced hydrogen molecule in the cycle, you can see the produced molecule can be stored in the magnesium based solid hydrogen storage system or liquid. There is also the liquid based solid hydrogen storage system. So now mainly I will discuss here the magnesium based solid state hydrogen system. So I take this example. So the produced hydrogen can be stored in the cylinder, in the form of cylinder, and we can transport one place to another place from, like, in the big truck, and we can utilize this fuel in the form of small, like fuel cell vehicle or electric bikes. And after the event, after the combustion, there is no any uh, toxic effluent in the atmosphere. Only there is a hot air and water will release into the atmosphere, and that will environmentally that will also convert into the drop of water in a small amount. So finally, this cycle, while once this technology will rotate, there is no any toxic effluent in the atmosphere. Okay, so here there are four different methods. Recently, we are working for the production of hydrogen, and it is for its utilization. The first one is the high pressure hydrogen, second is liquid hydrogen, third is organic hydrogen, and fourth one is solid hydrogen. So let's discuss one by one. The next slide, please. Next slide.
Yes, sir. High pressure hydrogen.
Okay, so in the high pressure hydrogen, the high technology maturity has been used before, many years before, in Japan. And they, for that technology, around 70 megapascal hydrogen pressure have been used to compress the hydrogen into the cylinder. After a while, there is the time to time there is research goes on, and recently in China they are using 35 megapascal pressure. And most important thing, the hydrogen can be stored in cylinder. Only 1% hydrogen can be stored in the big cylinder. Okay, so we cannot increase the percentage. So the quantity of the storage is very small, very small. Even in the big truck, while you transport one place to another place, mm, only 300 kg of hydrogen can transport with the big truck, with the help of big truck. So that is very cost effective. So to improve uh, the weight of hydrogen storage in the bottle, we are using some different kind of materials, like magnesium materials. Like in liquid hydrogen, there are like toluene, methyl cyclohexane, toluene, this kind of structured liquid hydrogen molecules we are using here. So okay, we'll discuss later that one. So here I want to say that only 1% of hydrogen, as per the capacity, can be uh, stored into the big tank. So initially, when this company Toyota Goshai, they have built a hydrogen car, and they used two cylinders, and in the, as per this two cylinder capacity, around 650 kilometers they can use for the car. Okay, and there is some safety reasons. That's why they changed another version, and they use the three cylinder, and then they have increased the mileage up to 850 kilometers. However, there is many challenges here, because the if this kind of hydrogen connection, it takes a high insulation, and it is little dangerous, while the insulation is not so good. So day by day, the research is going on in this field as well. With the help of Toyota Gosai in India, hydrogen fuel cell vehicle also working. I will discuss next. Next one about the mileage. Mileage of a fuel cell vehicle. If we use 1 kg of hydrogen, approximately we can use 33.6 kilowatt of energy. And that particularly, suppose if we want to go 100 kilometer, we need at least 0.9 to 0.8 to 0.9 kg of hydrogen for 100 kilometer. And meaning is that there, if you are using typically for 1 kg 100 and 125 kilometer of range can be used in the model fuel cell vehicle. The engine is designed for that purpose. Nowadays, the 1 kg of hydrogen is approximately 7 to 800 rupees. But for the transportation and storage also cost challenging now. This is only for production cost. So transportation and like we need some kind of cylinder, small cylinder, and we need to high equipped connector. So otherwise, if there is a leakage, that is a big problem for users. So now it is also under the uh, consideration for the safety issues. Next. Okay, the next one is a liquid hydrogen technology. So you can see here the big tank is here. Okay, so while we liquefy the hydrogen into such big cylinder, almost 30% of the energy is wasted. It means that for the liquefaction consumes more than 30% of the energy content of the hydrogen. That is very, very cost effective. Okay. Second, the we need because for the liquefaction we need to uh, cool the hydrogen gases are approximately minus 253 degrees centigrade. And for this, for that big cylinder, the insulation tank is very large. So the technical requirement, it need the excellent insulation protection. If 30% energy is wasted, it means that that is also the high cost effective. So this technology have also a challenging. Okay, so still work is going on that. But for the liquid hydrogen, the insulation is cost of the energy liquefaction is very high. Next. Next is the liquid organic hydrogen. So the in liquid hydrogen, what we are doing here, you can see in the cycle, almost once we uh, once we store the hydrogen using the toluene, we can store the hydrogen into this kind of liquid organic materials, and we can convert in toluene into methyl cyclohexane. And for the deactivation or dehydrogenation, we need almost 320 degrees centigrade high temperature. That is a big challenge. So in this technology, the dehydrogenation temperature is too high, and we are still working for this technology to change the using the different kind of catalysis, so that we can reduce this dehydrogenation temperature. For this technology, we are also working. There is some benefit as well. This liquid organic hydrogen carrier can be used for long term storage and long distance transportation of hydrogen. So for the storage purpose and for the transportation purpose, this technology is very good. Only there is a drawback we need to consider, and we work for that one, is to decrease the dehydration temperature below the 320 degrees centigrade. Okay, please next. Okay, now I am going to discuss about the magnesium based solid state hydrogen storage technology. Okay, in this technology there is many uh, safety concern. Suppose like magnesium is available, is earth abundant, it is easily available, cost very inexpensive. You can see in magnesium the hydrogen can stored approximately 7.6 weight%. This is the practical level, but in the lab maybe little bit 6.5, 6.8 something as per the experimental conditions. So the standard is 7.6 weight% of hydrogen we can store into the magnesium. And about the heat resistant, we can say the magnesium is a very excellent for this resistant. We can recycle magnesium, allows can be recycled uh, after hydrogenation and dehydrogenation process. Okay, so you can see here in the hydrogen gas can be stored into the metal like magnesium, and after the hydrogenation, that is a exothermic process, there is magnesium hydride can be formed, and after the dehydrogenation again magnesium can be reformed to further next base use. Okay, what is the drawbacks or what is the limitation of the magnesium? The number one, while we using magnesium based materials, they have very low hydrogen absorption and desorption capacity. Number two, high hydrogen absorption and desorption temperature required. We need to high temperature. Then number three, if we need a high absorption and high desorption temperature, it means that also we need high activation energy and enthalpy. That is the main limitation. And how we can resolve this kind of limitations using if we need to use this kind of material for hydrogen storage. So how? So what we are doing in our research recently, we are going to change the transition metal catalyst, or we are adding some new kind of transition metal catalyst or carbon composite catalyst. Second, we are incorporating some transition metals into the magnesium hydride to construct a new kind of alloy, nanocrystals or composites. We are using several different kind of method for processing methods such as rapid solidification, uh, severe plastic deformation process. Recently in my lab, we are using many different kind of plastic deformation processes. Then third one, accumulation roll binding. This is the new kind of technology. For this kind of strategies, we are going to apply to improve the performance of magnesium based storage materials. Next. Okay. Future hydrogen car in India. Actually, there are many companies in India already started. I think 2 years before our Minister Nitin Gadkari sir, he went to Parliament in hydrogen car. I remember. So, okay, there are some specific model initiatives in India nowadays. Toyota Mirai is also, they are working in the sedan type of car. That is also a kind of pilot project supported by the ICICI Lombard and Toyota Kirloskar Motor Company. So then another one is the Hyundai Nexo is also building a SUV nowadays. Inos Grenadier testing a hydrogen fuel cell variant of their SUV car. And another in is the MG group, MG Hector group. So MG in INIC 7. So there are different varieties of sedan and SUV cars will be expected in the future market in India, and these all are under uh, construction, or you can say under investigation. Next one, please. Okay, this last 1 year back, in the February 2024, our Prime Minister also inaugurated a ferry that is operated in the Kochi shipyard nearby. So this is also operated by hydrogen powered vehicles. Uh, there are some different kind of truck and buses also. Um, uh, there is by Tata Motors. Next. Okay. Now let's come to the chemistry part. So we can talk about the energy barrier of hydrogen absorption and desorption. Okay. So in thermodynamic point of view, to release 1 bar of hydrogen, approximately 560 Kelvin uh, temperature is required. And according to their desorption enthalpy minus 74 kilojoule per hydrogen per mole per hydrogen, and entropy around minus 135 kilojoule per kilo per mole hydrogen. So the we need to here we need to decrease the deactivation temperature. We need to change the microstructure of the magnesium materials, and we have to decrease the deactivation temperature so that we can save some energy, and we can easily in safe mode, stable mode, and in low cost transportation mode we can operate, we can use, we can store, and transport one place to another place using this magnesium material. So some research is very much required to change the microstructure of magnesium hydrides materials. Next, please. Hello. Okay. Okay. Principle of hydrogen storage and production. First of all, I would like to talk about the hydrogen storage, hydrogen storage in magnesium in cylinder. So we need to consider some points. Number one is that the place where we kept the cylinder, the temperature should not exceed 52 degrees centigrade. The first point. The second one, we need to separate the cylinder from some oxidized material like oxygen, chloride, and other oxidized gases. And at least we need to keep this cylinder from those materials at least 20 feet away. Otherwise, this is a little bit problematic. Nowadays in China, also in our lab also, initially we were using in the same building, the reaction were performed in the same building, but for the safety reason, we have to separate that lab from, from the crowd place. So we have another lab and that is far from our university. So they are not allowed inside the. There are other classes and other labs are going on. So for safety reason, there is a restrictions for this study as well. So we need to consider two main points. There should not high temperature nearby in the environment around 52 degrees centigrade. We need to keep away almost 20 feet away from oxidized gases like oxygen, chlorine, and other gases. So, okay, other thing we have already discussed about the hydrogen storage capacity of magnesium is very good, around 7.6 weight percent, and thermally it can be reversible. High purity of hydrogen can be released and can be stored. And next one, please. Okay. Now there is two important things here we have noticed. The traditional high pressure gases hydrogen storage and transportation technology faces two main challenges. One is first is the safety, and then second is the economic. If the cylinder, either that is liquid hydrogen or solid hydrogen or any kind of hydrogen, if the insulation is the if tank is not insulated very nicely, that can be explode very easily with the contact of any other oxidized gases. That is the one major problem. Second one is the price. Nowadays in China, the price of high pressure gases hydrogen, it is 80 yuan. 80 yuan, it means around 1000 rupees per kg. And mass of hydrogen storage and density of cylinder is only 1%. So you must use some other kind of material to store the hydrogen into it. One thing, this is only for production of hydrogen. 1000 rupees I am talking about only for production of hydrogen, not about the storage and not about the transportation. So that cost also need to be considered. So when the production, storage, and transportation, three challenges will resolve in the cheap prices and low prices with particularly safety purpose, then this technology will come into the market, and we can use in future. We can use the small cylinder. I will show you some later. I will show you some application. We will use the small cylinder, and then go like we are using the LPG gases cylinder. Like similarly, the small cylinder will the accordingly, and we only need to connect in the future, and then it can generate the electricity and we can use further. Next one, please. Hello. Okay. Thank you. Okay. So here we are talking about the sources of the hydrogen for the hydrogen production. So we can see in our nearby cities, there are many different kind of coal refinery factories, different kind of chemical productions factories are going on. So now I am taking example of the Yulin. Yulin is the small city, but this is very much uh, loaded with the fossil fuels, fossil products. So if you are using here every year, raw coal gas production by production in the form of blue carbon, 97,000 ton per year. Coal chemical byproducts, hydrogen only by methanol outgassing 90,000 tons per year. Refinery exhaust like oil 10.7 million per ton. Coal alkali byproducts 26 tons per year. Production of ethylene from ethane by light hydrogen cracking 300 tons per year. And there are other sources of hydrogen production from renewable energy resources. So finally, what I am talking about, that there are toxic effluent, or there are some raw coal chemical refinery products. This all can also be used as the for the production of hydrogen as a raw material. Okay, recently there are four different kind of raw materials nowadays we are using. Then in the form of natural gas around 48%, oil is around 30%, coal is around 12%, and there is water splitting around 4% approximately. So these are the different kind of resources from where we can collect the hydrogen, and we can use uh, in the hydrogen technology for produce the hydrogen energy. Next one, please. Okay. Now we are is now I am going to talk about the research direction. Here in our lab, there are two different kind of magnesium-based hydrogen materials we are working for. The first one is magnesium-based hydrogen energy materials, and then second one is methyl cyclohexane organic liquid hydrogen storage materials. So for the time being, I only discuss about the magnesium today. If there is another opportunity, I will discuss about the liquid hydrogen in the next one. So for the magnesium, we are also going to produce in the large scale, and continuously we are doing some different kind of experiments, different kind of equipment we are using to for the bulk hydrogenation and dehydrogenation method and technologies for industrial scale preparation. Next one, let's discuss about the magnesium based researches. Okay, this is the ball milling which we are using in our lab. So there are two main equipment I will discuss today. First is the ball milling and second is the PCT, pressure compressed temperature. The first one is ball milling. There are several different kind of ball milling used for this method. We are also using some advanced ball milling. In ball milling process, we all know that we can grind the particles in very small fine particles using the iron balls. There is an iron ball in different size of iron ball we can use. The ratio for the material in the iron ball we are using usually 40:1, and this the middle one is a high energy uh, ball milling. uh, for that one we need to use around 0.45 megapascal pressure and around almost 900 rpm 900 rpm per minute speed. So this is the high energy ball miller, and especially this kind of ball miller is why we are using, because we need to change the microstructure, we need to incorporate the different other transition metal into the magnesium. So this kind of ball miller is very useful to change the microstructure and incorporate in the transition metals into magnesium based materials. Next one. Okay. Now the PCT, pressure composite temperature. Okay, I will discuss in short the methodology of the PCT, because maybe some of you guys already know this technology, and some of the I hope some of authors, the audience, this is new for them. The first one you can see here, there is a knob, the first one. So this is the gas kit, and there is a in middle one, this is the heater. In inside the heater there is will in the pencil like uh, space is there. We need to put the magnesium materials on it. Okay, This is the first step is called a sample loader into the tube. There is tube like material. We need to put the materials into the tube only, and then we can connect and place the holder. And particularly, we need to check the temperature sensor and other washers is equipped properly. The next one, first one is the sample loading into the tube. The second one, second one, please. Okay, okay. Now the second step, we need to check the leakage. There should not be any leakage, because the high temperature also be required for that one. So there should not be leakage. And how we'll check? Once we will check, we'll on the button, yes, click. So there will be blue dialog will be open. It means that the system where we have uploaded the sample, that is perfect now. And here we need to set around 22.63 minutes and click continue. And the blue, while we click the continue, the blue box where disappears. Okay, so it means that our system is okay, loaded, sample is loaded properly, and there is no leakage. Please next, quickly, no time. Okay, here you can clip the knob no down, and then you can set vacuum up to 10 to 20 minutes at room temperature. That is very sufficient. So there will be no any kind of small other gases, like if we are using the magnesium inside, and if there is some oxygen left into the sample, it means that that can make a, mm, ring of magnesium oxide, and then they can hinder the uh, process, hydrolysis process. Next one. Okay, so there is some calibration things, and we need to, I think we need to calibrate this instrument in room temperature, and we have to set almost 8 minute time, and then we need to further continue next. This is not much important, just go through the next. Actually, I prepared for the students this one. Go next. Next one is the heat while evacuation. Go next. Next one is the high temperature calibration. Also for 8 minutes, we need to check the high temperature is maintained in particular temperature or not. We have to check that one as well. Next one. Okay. Also, next, this is dynamic testing. We need to initial and final temperature. We need to fix the pressure around 60 0 and 60 bar. Next, to measure the kinetics in the particular temperature. Yeah. Next one, please. Yeah. Okay. So I'm going to discuss. We have 45 minutes left already. So now we are going to discuss one by one. There are three different researches. The total allowing us to be magnesium 10 cobalt for the enhanced hydrogenation performance. Then second is the hydrolysis hydrogen generation behavior of mechanical chemical reactions. We are using here nickel, cerium and lanthanum binary alloys along with magnesium hydride. The third one is the microalloying of yttrium and nickel into the magnesium based hydrogen storage system. The next one, please start. Next. Next. Okay. So The first one, mechanical alloying for fabricate magnesium tin cobalt for the enhanced hydrogen performance. So this work we focused especially for the checking the performance of the hydrogen using the magnesium cobalt alloy. Mainly we investigate here the effect of ball milling first process, effect of ball milling time. We used 2 hour, 10 hour, 2 hour, 8 hour, 14 hour, and 20 hour time. Uh, both for the hydrogenation and dehydrogenation kinetics, thermodynamics, as well as the we study the microstructure of the magnesium alloys. So here you can see the XRD, the first one, XRD A, number A. There is diffraction peaks of different kind of diffraction peaks of magnesium cobalt, magnesium 2 cobalt, magnesium cobalt dicobalt, and magnesium oxide. So here you can see the magnesium oxide. It means that there is some impurity of oxygen present before the hydrogenation. Okay, so this magnesium hydroxide or magnesium oxide or magnesium hydroxide is present in the system. It is that can slow the kinetics, hinder the kinetics, or sluggish the kinetics. Okay, so after the hydrolysis in the next XRD, like B, you can see the B. There is a sharp peak of the magnesium hydride, magnesium 6 cobalt 2, hydrogen 11, magnesium cobalt hydride, and magnesium. There are different kind of sharp peaks are available. Okay, so it means that there is a uh, uh, there is attribution of the cobalt into the magnesium. That's why there is a sharp peak. You can also see in the picture C, and there is a in the box, in green box, you can see there is 1326 centimeter inverse and 1125 centimeter inverse. There is a sharp peaks, sharp wavelength peaks on that particularly position. That is the first one, 1236 centimeter, is belongs to the magnesium hydride, and another one is belongs to the oxygen species. It means that before the hydrogen there was magnesium oxide, hydrogenation. After the hydrogenation, the magnesium oxide converted into magnesium hydride and oxygen species. So this is the experimental evidence in the picture C. Next one. Next one. Okay. So you can see the XPS. XPS analysis before and after the hydrogenation. You can see the magnesium is 1s, cobalt is 2p, oxygen also available is 1s, and carbon is 1s position. Okay, so here you can see in the picture B. Okay, there is magnesium, sharp peak of magnesium, and the small peak of magnesium oxide, both present during the before the hydrogenation, and that can that indicates that after the hydrogenation, you can see the picture E. Okay, there is a sharp peak of magnesium, and there is another peak of magnesium hydride. Okay, so it means that there is a magnesium oxide has converted into magnesium or magnesium hydroxide. Number C, you can see in number C, uh, there is a distinct peak of corresponding cobalt 2 PS. So there are three kind of cobalt: cobalt 3 plus, cobalt 2 plus, and cobalt 0 oxidation state in before the hydrogenation. After the hydrogenation, you can see the cobalt 3 plus is shifted from 794 to 800.8 electron volt. Similarly, cobalt 2 plus is shifted from 780 to 783, and cobalt 0 is shifted to 777 to 778. It means there is that this result suggesting that the formation of corresponding hydrides during the hydrogenation and leading to enhanced bonding energy. So bonding energy has increased. These results support the role of cobalt in magnesium hydrogenation by providing electron pairs and create multivalent environment to enhance the hydrogen storage kinetics. Okay, the next one. The surface morphology of magnesium 10 cobalt particles. Okay, so while we see the figure A, D, G, J, like this one, Saras, next slide is surface morphology. Hello.
Yes, sir.
Surface mass morphology is open. After the XPS analysis, there is surface morphology. If you guys already seen, then I can continue that one. Okay, the surface morphology of magnesium 10 cobalt particles. So we can see in the first A, D, G, and J, the particle size is bigger, and yeah, now I can see properly here. Okay, so this, after when we see the high magnification, you can directly check the pre-hydrogenation CFINL figures. There is some micropores and micro cracks also available. There is some rough surface with dense and micropores. So it, okay, so in the first page pre-hydrogenation, you can see there is some dense and rough phases available, and the micropore and micro cracks is less. After the post hydrogenation, you can check the CFINL figure. In after the post hydrogenation, you can see there is more cracks, more micropores, more microenvironment available. There is a less rough and less dense area available in the during the hydrogenation, post hydrogenation in 2 hour, 8 hour, 14 hour, and 20 hour samples. Okay, so what is the output here? When we using the high energy ball milling fracture, the particle size is very cracked, more pores, which help for hydrogen diffraction transportation, which promotes to constant contact between the alloy particle and the hydrogenation. Hydrogen into this kind of system, and that can reduce the deactivation temperature as well. Okay, next one. Next one is the particle size distribution. Okay, you can see here, while we using the ball milling process, the particle size distribution for 2 hour, 8 hour, 14 hour, and 20 hours. Okay, you can see here, in case of 14 hour, the particle size is smaller. Okay, almost around 38 micro m. Okay, so you can see here the after the continuous growth in different time scale, when ball milling time increases, the crack and pores become more larger, and when it increase the surface area become more larger, and increase the surface area, and then more nucleation sites for magnesium hydride that can shorter the diffraction transportation distance from the hydrogen gas, that is augmented the number of diffraction channels, and that finally facilitating the dehydrogenation process of magnesium 10 cobalt. After the hydrogenation at high temperature and pressures, many cracks and holes were generated on the surface of the particles, and more rough surface of the particles means the metal alloys are well hydrogenated. So this surface phenomena can already also connected with the particle size in this displayed in the figure, and you can see in the first one the 52.82 micro particle size shows in the figure 1 in the topmost. You can see in the black curve. Okay, it indicates the plastic deformation while the particle becomes smaller up to 14 hour, almost up to 14 hour, that the particle is 38 micro m. That is suggesting that the mechanical energy is converted into the internal energy. However, after the 24 hour, you can see in the inset the particle size is accumulated, means increases little bit because of the accumulation of the particles. So I want to say like that after the hydrogenation, you can see in the figure B, the particle size decreases due to the increase in the lattice stress. So finally, in the 40 hours, pore size distribution curve also shows here. You can see pore size distribution curve shows micropores in both pre and post hydrogenation. That can be when you analysis that can exhibit the type 3 and type 4 kind of adsorption isothermal process. So in this picture, in during the both in post and pre-hydrogenation, 14-hour growth of the particle size is 38 micrometer, and that particular particle size in condition, the micropokes and microcakes in that environment is high in condition. So let's see in the further the kinetics and thermodynamics. Next slide, please. You can see the next hydrogen absorption and desorption kinetics. Okay, you can see the the picture number D. There is a BM 14 hours. In the 14 hour, you can see how hydrogen uptake capacity and release capacity before the hydrogenation. It is about 5.93% weight percent or 6.07 weight percent. Okay. After the dehydrogenation, you also can check in the same time, 14 hour. It is about 4.8, 4.80 and 4.83 hydrogen absorption and desorption kinetics. Okay, so here there is no much there is according when we compare with the different temperature different samples while of the growth of the growth at 2 hour, 8 hour and 14 and 20 hours, the 14-hour particle size growth is the better one, and for the hydrogenation uptake and hydrogenation release, both hydrogen and before dehydrogenation is the result is better in that particular condition. Next one. Okay. Here okay, you can see in the table 2, magnesium 10 cobalt ball milling for 14 hour. Okay, for 5 minutes the at 383.4 degrees centigrade, it shows the really hydrogen release temperature. Okay, in that that particular temperature, almost 5.93 weight percent of hydrogen can be released. Okay, it means that The you can also see in this picture, maybe it is clear in the big screen. Okay, so almost in the green one they have 383.4 degree centigrade. Okay, so what is the conclusion here? The conclusion is that the synergistic effect of magnesium cobalt hydride like Mg2CO5 H5 or Mg6CO2 H11, there are two kind of materials that lowers the absorption plateau pressure according to the hydrogen uptake. If the plateau is lower, then it means that we can deactivate the hydrogen in low temperature. Temperature can be decreased. After the dehydrogenation kinetics, you can see here for the 14-hour itself, 124.89 kilojoule per mole, that is lower than the standard pure magnesium hydride material. For the pure magnesium hydride material, the deactivation kinetics is around 160 kilojoule. But in our case, for 14 hours, it is shows around 124.89 kilojoule. That indicates our system has a faster dehydrogenation peak temperature, it particularly 300 around 383.4 degrees centigrade. So the activation deactivation energy is around 124.89 kilojoule per mole in our system. Okay, the next one, let's talk about some thermodynamics. You can see here in the figure B, delta H enthalpy shows around 84.76 kilojoule per mole. It is very compatible with the magnesium hydride materials. In thermodynamic, uh, if the ball milling effect, in this process, our ball milling affects thermally, our ball milling process help to uh, decrease the temperature and improve the kinetics. This is because of the changes of the microstructure, like more cakes and more pores in the magnesium cobalt system. Next one. Okay. Now the second one is that hydrolysis hydrogen generation of behavior of mechanico-chemical reactions. So now for this work, we develop a mechanico-chemical strategy to prepare the magnesium materials. While we explore the magnesium material into the oxygen atmosphere, that can easily create a ring in the surface of the magnesium is the magnesium oxide. Further, that is magnesium hydroxide. That kind of ring, magnesium oxide and magnesium hydroxide ring is can be hinder the kinetic, lower the hydrogen capacity. It can poor environment. It can shows the poor environmental stability. So to avoid such kind of issues, we prepared another method that is called MCR strategy. So what we did here, we used the high energy ball milling using the 0.45 megapascal pressure and speed around 900 RPM, and we prepare the material, different materials like incorporated with the magnesium, the incorporated of some transition materials like nickel, lanthanum, uh, and into the magnesium, and then we prepare the magnesium based alloys and we exposed into the atmosphere. It shows very high is environmental stability. After the hydrolysis, it is the kinetics, it also shows the very fast, and the hydrogen capacity is better than before. So let's discuss the results. Next slide, please. Next slide, figure 1. Next one, figure 1. Hydrolysis hydrogen generation capacity in rates of magnesium based hydrogen binary alloys. Here we prepared magnesium nickel, magnesium cerium, and magnesium lanthanum materials using the 3.8% of sodium chloride at 298 Kelvin. You can see here in the figure number 1, the reaction kinetics is very slow without you in using while we using the simple ball milling. After the we applied the mechanico-chemical strategies, everyone sorry, I'm interrupting here. um, the slide shows figure 1, hydrolysis hydrogen generation capacities. Hello,
Yes, sir.
the slide is right slide because yeah, slide is right one, right? Okay, thank you. Okay, so in that particular, you can say that activation uh, of hydrogen hydrolysis rate is very sluggish in picture number A. Okay, then while you go to the MCR strategy, and you can see the picture number C and D. Okay, you can see even within the 2 minute, the activation the hydrolysis hydrogen capacity is very high. Even you can see in the D, within the 2 minute, the this is a very much activated in all the cases. But in case as compared to the magnesium nickel, magnesium cerium, and magnesium lanthanum, and you can see magnesium lanthanum is better performance as compared to other two materials. Next slide, please. Okay, here we also studied about the different temperatures like 290. Next slide. I just see the previous one. Next slide, figure 2, capacity time curve. Okay, so in this work, we also studied about the effect of temperature. While we increasing the hydrogen storage capacity temperature, the in high temperature the hydrogen capacity also increased. This method, we also compared with different previously published articles about the similar system, and our system shows very you can see in the table 2, the our system shows low activation energy around 26.6, 30.8, and 23. This is our work. So in case of magnesium nickel, it shows 26.6. In case of magnesium cerium, it shows 13.8, and is in case of magnesium lanthanum, it shows 23 kilojoule per mole. So this system is also quite better, and this is published in Journal of Material Research Technology as well. The next one, next slide about the XRD. Okay, in the XRD you can see there are different kind of SAR peaks in case of magnesium nickel, and you can see in magnesium nickel there is a magnesium nickel hydrogen, magnesium hydride, magnesium nickel hydride, different kind of magnesium nickel hydride. But apart from that, there is also magnesium oxide present before in atmospheric atmosphere. That is not good in magnesium nickel. It compared to magnesium cerium, you can see there is no any kind of oxide of cerium present. Also in case of magnesium lanthanum, there is only lanthanum oxide, and magnesium lanthanum only present. After the hydrolysis, you can see there is very sharp peaks of the magnesium hydroxide, magnesium nickel, and magnesium lanthanum were present. So the SAR peak shows that there is incorporation of nickel into magnesium, and there is no any kind of magnesium oxide and magnesium hydroxide present into the system. So this is also help to increase the kinetics. So next one. Next one, while we go to the morphological analysis of this MCR binary based strategies, so you can see the figure A, D and E, G. This is the big particle size is very irregular, particle size is very big. While we go to the high magnification, you can see in case of magnesium, nickel, there is some micropores also, there is some rough surface also available, but there is micropores. But in case of magnesium cerium, the you can see there the most of the pores is dense and flat. It means that that is less hydrolysis. There is a less hydrolysis. And while we go through that magnesium lanthanum, there is more number of micro cracks, micropores, and layered structures. It means that there is a plastic deformation is high in condition. And then uh, next one, you can see while figure number 5, while we go through the byproducts of MCR, morphology, I will check the morphology of byproducts of MCR based binary alloys. You can see, you can see that the fluctuated morphology shows in all the system. But while we go to the high magnification analysis, you can see in the case of magnesium nickel, there is a spare and loose particles as well. There is half portion is dense and continuous. In case of magnesium cerium, almost all uh, place is dense and continuous uh, morphology. And in case of magnesium lanthanum, you can see there is almost area is spare in loose. It means that if there is more place is spare in loose, then that in case of magnesium lanthanum, that is a very complete hydrolysis. So as compared to the nickel and magnesium cerium, the magnesium lanthanum uh, material is better for the hydrolysis, hydrogenation and dehydrogenation process. Okay. Now the next one, maybe I will take 10 to 15 minutes more. I will finish that on time. Next one is third one is the microalloying of yttrium and nickel onto the magnesium hydride material. That paper also published in the International Journal of Hydrogen Energy. Uh, okay, here uh, first up first of all, I would like to discuss why we are incorporating the such kind of transition metal, yttrium and nickel or cerium or lanthanum into the magnesium hydride. So here we are using the yttrium and nickel to incorporate into magnesium hydride because the transition metal shows less electronegativity than the magnesium, and then it can help to enhance uh, uh, decrease the deactivation temperature and increase the more hydrolysis process. So let's see, according to the XRD, you can see there are very mixed phases of magnesium hydride, magnesium yttrium, magnesium nickel well present. Before the this is called HBEM 12H state. After that, the saturated state, after the absorbing state, you can see there is very sharp peaks of magnesium hydrogen, magnesium yttrium, magnesium yttrium nickel present. It means that there is a magnesium only the in figure 1 there is only the sharp peak of magnesium is reduced, and there is only magnesium hydride and magnesium yttrium nickel peaks are available in this page, the last page, the third one. Okay, so we can also see in the bar diagram. In the initially first phase, you can see there is a magnesium hydride. You can see the red one. 6.38% of the magnesium present in the first step. Second step, magnesium is less. And the third step, while after the incorporation of yttrium and nickel, there is less and very, very less magnesium, only pure magnesium present in the system. It means that this phase structure, after the SAR picks different SAR picks in different positions. After the analysis, it shows that there is incorporation of yttrium and nickel into the magnesium hydride. Next one. Okay, the mechanism. There are four different kind of hydrogenation process. The first one is the hydrogen dissociation. It means that hydrogen molecule will dissociate into the hydrogen atom, and that dissociated hydrogen atom will penetrate the surface of the magnesium or yttrium. Okay, that is surface penetration process. After the continuous penetration, the hydrogen in magnesium, between the hydrogen and magnesium, there is some boundaries will interrupt, and there is a inter hydrogen diffusion phase. In that phase, there is a bivalent and trivalent phase will appear. After the complete nucleation, that is called hydride nucleation. And after the complete growth, you can get the magnesium hydride, magnesium yttrium nickel hydride phases uh, of the alloys. Okay, next one. Okay, while you see the EDS image of these three different particles. So first one is first A and B source for the pure magnesium. The second one is for magnesium yttrium. The third one is for magnesium yttrium and nickel. So we incorporate into the while incorporation of, you can see in the picture like particle size diagram. Okay, there is big particle is shows the magnesium only. While we incorporate into the yttrium, the particle size decreases. While incorporate into the nickel into magnesium yttrium, it means there is ternary phase. First phase magnesium particle size is bigger. Two phase magnesium yttrium particle size is binary alloys magnesium yttrium particle size decreases. Ternary alloys magnesium yttrium nickel particle size more decreases. Also, we can see in the pictures also here in the EDS image pictures, it clearly shows that the particle size decreases after the incorporation of the binary and ternary alloys. Okay, next one. Here in EDS table, simply we take the 9:1 weight percentage for a magnesium yttrium. After the result, it is around 9.5 and 0.5 weight percentage, atomic percentage. Also, while we use the 9:1 for the magnesium yttrium nickel, and similarly after the final result after the EDS mapping, it is shows 9.5, 0.5, 0.5, something like that. It means that there is a large number of yttrium incorporation, around 2.78 weight percent, and little less than around 2.18% nickel atomic weight percent incorporation happens in the magnesiums. Next one. Okay, figure 5, you can see the high resolution electron microscopic. Okay, while we see here in the picture number 1, HREM picture number 1, you can see the mixed phases of magnesium hydride, magnesium yttrium, and magnesium yttrium. This shows mixed phases. Okay, you can also see in the picture number F. Okay, so this is the green one is for magnesium, and then the yellow one is for yttrium, and the pink one is for nickel. So there is mixed phases of the alloy incorporation, means the element incorporation appears in the pictures, high resolution pictures. Next one. While we discuss about the kinetic properties of activation in deactivation, hydrogen absorption, in all the cases you can see the similar trends were found in the first, second, third. First, like for the nickel, for the magnesium cerium, magnesium lanthanum, in all the cases similar trend were found, but The hydrogen capacity, if you can see in the picture number 1, it is shows around 4% approximately in case of magnesium nickel. While we see the picture number B, it shows around a 5 point around almost nearly 6% magnesium in case of magnesium nickel. And for magnesium lanthanum, it can source also the 6%, 6 weight% or 5.9 weight%. In the similar trend, we are present in both the absorption and release kinetics. Next one. Okay, we can clearly see in the table 2 kinetic process. You can see here in case of magnesium yttrium in 350 degrees centigrade, and also you can see in the magnesium yttrium nickel in 350 degrees centigrade. Almost for 5 minutes, 5.88% and 5.73 weight% respectively, it absorbed the hydrogen capacity. So in case of magnesium yttrium, the hydrogen absorption capacity is bit high, around 5.88% at 350 degrees centigrade temperature. Please go ahead. Next one. Next one. Okay. So while we analysis the thermodynamic properties of this material, we can see here there are one plateau, sharp peak in case of magnesium yttrium, but there is 2 different plateaus find in the case of magnesium yttrium and nickel. And there is an incorporation of nickel material element is very less in this system, because the incorporation capacity of nickel is less as compared to the yttrium. And in case of while we check the wait a moment. Yeah, please go next slide. Next slide will be more clear. Yeah, next slide. Yeah, you can see. Yeah, so while we check the DSC and Kirchner's curve here, so in case of magnesium yttrium, the deactivation temperature is almost about 425.31 degree centigrade. But after the incorporation of nickel into the system, it is converted, it is changed almost around 300 it is about 229.90 degrees centigrade. So while the incorporation of nickel is very important into the system, that we shows very large deactivation temperature after the incorporation of nickel. So while we check the magnesium yttrium and nickel hydrogen absorption and release kinetics here in the right side in the cyclic curve, absorption is around 6.6 weight% and desorption is around minus 5.9 weight%. So there is no very drastic change for absorption and desorption. And this system, this material can shows around almost 6%, 6 weight% absorption and desorption capacities of hydrogen release. Next one. Next one, you can see in our system under the condition of 300 degrees centigrade, the system can absorb hydrogen around 7 weight% for 15 minutes. You can see here, and release hydrogen around 6 weight% within 12 minutes. You can see in the this magnesium hydrogen TiF2 system. And this is the electric vehicle we are using here for charging, discharging. And next one, I am going to show some application. So Saraswati, the next last slide, please, and play the video. Okay, before to start the video, wait a second. So I want to explain first. There is an empty bottle. Okay, you continue. Yeah. There is an empty bottle and there is a magnesium material. They mix together and connected with the fuel cell, and directly the electricity is generated around 20 watt. We just use the material, pure water mixed together, connect with the fuel cell, 20 watt electricity generated in quickly in this material. Next one, next application. Okay, accelerating, and then you can see, yeah, you can see here there is a water inside beaker. There is two different kind of magnesium hydride material. One is hydrogenated, the light one is without only pure material, non hydrogenated, and the dark one is hydrogenated. Okay, so while we put the hydrogenated tablet of magnesium hydride, there will be large number of hydrogen will release quickly. You can see in the beaker. And if we put the dehydrogenated material, there is only less number of magnesium hydride available. You can see clearly the hydrogen gas will release. Yeah, you can see here there large number of hydrogen gas is releasing. Okay, now third one. Here you can play continue. Here also the same process, pure water, the material will mix with the pure water using the small bottle and will connect with the small car, and immediately the car will start. Immediately there will be hydrogen power will generate, and then car will run. Okay, you can check. So this is a small amount we have used for the practical purpose, and for the particularly for the large amount we are also working on it, and I hope we will succeed for the hydrogen storage and transportation process using the magnesium hydride hydrogen materials. You can see the car is running. Okay, it is done, Saraswati. Hello.
Yes, sir.
Yes, please go to the summary and conclusion slide. Okay, in the summary, the first the incorporation of cobalt can provide different kind of nucleation site, such as magnesium cobalt hydride H5, magnesium cobalt H11, which is not only improve the hydrogen absorption rate capacity, but also it is favor the decomposition of magnesium hydride. The second one, about the similar system for the ball milling time, like 14 hours. It shows very excellent synergetic effect in while we grow the materials into the 14-hour ball milling time. This is our conclusion for the first talk. Second one, while we use the MCR strategy to prepare the very environmentally stable and well accelerated kinetic material. MCR we have used the MCR that proved the effective way to activate the magnesium based binary alloys and isolate their environmental stability. Okay, so as compared to the magnesium nickel, magnesium cerium, and magnesium lanthanum, so magnesium lanthanum, wait a minute. In case of magnesium lanthanum shows a very good hydrolysis hydrogen temperature. Okay, and that can help to deactivate the hydrolysis temperature. Okay, then third one is the magnesium, yttrium, and nickel we used. So in case of magnesium, yttrium, and nickel, the hydrogen absorption capacity and hydrogen release capacity is approximate similar, and that particularly that compound also shows very good hydrogen storage capabilities. So the next one, this is my university where I am working, and this is the arrow. There is my place where I am sitting, and these are my colleagues. And recently we are working for to recharge the truck using the hydrogen material, hydrogen fuels, and we are working for that, and we are working to store the hydrogen into the big cylinders using the magnesium materials. There is we have also the magnesium fuel station, and we can store the, we have incorporated with some industries. So other magnesium materials, hydrogen magnesium hydride materials also can uh, store here. These are our lab where we are working recently. Next, some fundings. We got some fundings. Next. We got some funding, and in the Yulin city government, I got Yulin city high talent project about the hydrogen energy, and we are recently working for that one. The project is continue running, and these are some publications, recent publications from me and my group, and related to the hydrogen storage materials. And in acknowledgement, I would like to say thanks to my PhD supervisor and Professor K.K. Ghosh from Pandit Ravi Shankar Shukla University, Professor Guangjung Yang, Professor Shizuan Zhao, and Professor Xu Yunhua. These are also my Chinese professor. They are very uh, much help for to create my career in here. And Professor Su Yunhua, he is ex-president of Yulin University. I am recently working under him, and he is providing such a huge lab facility for the to study and work in the hydrogen energy technology. And many thanks to all of you. And first, I would like to say sorry to interruption of the internet, because in China the Google is not working, and sometimes it is very hard to connect the Google system. So I asked my PhD student, Miss Saraswati Sharma. I am thank to her also. Okay, so so finally, I would like to say thanks to all the organizing committee members from the Vidyadeep University to inviting me for such a such a good platform FDP program. And I hope if I have opportunity, I will uh, give another face-to-face lecture. Maybe there is some instruction, some disturbance in the system. So I would like say I would like to say thanks to all of you to listening me very patiently. And if there is some questions, please welcome. Yeah. Apart from that one, go to after two slide. I forget that one. If someone interested for some fellowship from China for the PG, UG, postdoctor, there are many there are website there are China scholarship council provide the scholarship also. So if someone interested from your university, you may can connect with me. I can help you to let the proceed further. And if someone get benefited in for higher education or something, I'll be more thankful. Thank you very much.
Thank you, sir. Uh, Participants, anyone has any question, you can ask now.
Hello, am I audible?
Hello. Yes, sir.
Yeah, myself, Dr. Anand Maitre. I am from
Yes, sir.
Gujarat.
Sir, good
My
evening.
question is that you said that hydrogen is getting released. So, what is the capacity of that hydrogen to produce the electricity and run the vehicle, and at what extent that vehicle can run, like in terms of kilometer?
Yes, sir. My initial slide, number 3 or 5, I have discussed about that one, about the mileage recently. Okay.
Hmm.
So if you are going for 100 kilometers, almost 0.8 to 0.9 kilogram of hydrogen is required. For that particularly, it depends upon the design of engine. Okay, like uh, I just consider Toyota Mirai company, and that company nowadays using 1 kg hydrogen, and for 100 to 100 and 100 to 150 kilometer range. That is a modern fuel cell vehicle. Okay, so according to the engine design, engine capacity, it can be decrease and increase. Like similarly, we are using the petrol car. If we are using the SUV and high motor car, the average is less. And then if we are using the simple car, domestic cars, so the average is little bit high, like 20. Some car has 20, some car has 10, or some car has 15, like that. So particularly 1 kg hydrogen would provide 110 to 125 kilometer of driving range.
Okay.
Sudan
And sir,
type of car.
another
Yeah.
another question, like you are basically this is a physical phenomena where this hydrogen is getting adhering on the different alloys. What we are talking about?
Yes, sir. Actually, I am working on the magnesium hydride materials. Magnesium,
Oh,
while we go to the principle for the magnesium, magnesium can absorb 7.6 weight percent of hydrogen. Oh, wait. Oh, no, 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 no. Hello. Sir, am I
yes.
audible? Yeah.
Yes, 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 you're audible.
Yes, sir. Let me continue. Sir, 7.6 weight percent of hydrogen can be stored in the magnesium. But in that particular material, almost 560 Kelvin temperature is
Mhm.
required to release 1 bar of hydrogen from the magnesium. 560
Okay.
Kelvin. Okay. So this temperature is very high, and we need to decrease that temperature. That is our aim for that magnesium material. So what we are doing, we are incorporating some transition metals like chromium, yttrium, nickel, lanthanum, cerium, different kind of mix. Uh, so after the incorporating, there is a proper incorporation in of transition metal into the magnesium. So there is some micro cracks, micro pores available. So that side, the number of micropores, micro cracks will be available. Then there will be increase of the hydrogenation that can absorb more hydrogen into that system. So we can increase the hydrogen absorption capacity if there is more cracks, more plastic deformation, more pores available in the structure. So we need to change the microstructure.
Okay.
That is our strategy, so that we can we can let absorb more hydrogen into that material.
Okay. Sir, one last question.
Okay, sir. Please.
So that why you are calling it absorption and why not adsorption? means since it is getting adhere, or you are saying that the cracks or pores are there, so within that your hydrogen
Yeah.
is getting stored.
We
So
call
it's kind of a physical
uh,
adherence. So
like
why do you call it
adsorption.
absorption instead of adsorption?
Okay, adsorption and desorption, like hydrogenation and dehydrogenation, similar process like that, not absorption, because that particularly gas phase hydrogen is going to absorb on the solid phase. Like, okay, so this is not absorbing, that is going to incorporate into it. So we can call it
Okay.
absorption. Yeah.
Okay, sir. Okay. Thank you. It was a nice presentation.
Thank you, sir. Actually, I'm also not confident what you guys listen to me because of this is the online system. Sometimes it is very terrible.
Yes, sir. True.
Yes.
Any
Anyone
questions,
has
please?
any question?
Yeah.
Participants, anyone has any question? You can ask now.
Uh, Hello, sir. Good evening. This is Dr. Sanjay here
Yes,
from
sir. Yes, sir. Good evening.
Rajkot, Gujarat. Uh, we are from the China. So currently you're working in the China. So in the China, still is hydrogen vehicle is it commercialized or not?
No. Not commercialized anywhere.
Mhm.
It is under working condition everywhere.
But in the Germany, somewhere we have heard the news that they are already there
Actually,
commercialized.
in Germany, long year before, I also read the newspaper.
Mm.
But uh, some vehicles already prepared, but due to the cost, as I said, for the production of 1 kg of hydrogen, we at least we need 1,000 rupees
Yeah.
only for production. For storage and
Mhm.
transportation, it also need to be considered that cost. So we need to continue work for that. In design, we need to uh, change the microstructure, we need to change the cylinder, we need to construct some, we need to consider some good different kind of material so that we can store the hydrogen
So
properly,
it
we
may be
can
in the
transport the
future, it
hydrogen
may
one
get
place to
commercialized.
yeah. So for the commercial, sir, for the commercial purpose, still it is in under working condition. So I'm not sure that I can say this year or next
Because a lot
year.
of the
But
research is going
still
on the
many
China
lots of
as well as in the
companies working on
Germany
it.
on this storage of the hydrogen.
Yeah. Germany initiated that bus services.
Yeah.
I heard that one, but I'm not pretty sure
Mhm.
that everywhere that is working. Maybe in some particularly place there where the hydrogen is available. Hydrogen. Suppose in Germany, maybe some place, some university, they have already hydrogen production unit, and they are going to operate that buses inside the campus. Maybe that is possible, not for public. I think that is possible
Yeah.
inside the campus,
That is
maybe that is
connected to the,
possible.
yeah. They're using the fuel cell in the buses, right?
Yeah, maybe in fuel cell here also we have fuel station, but that is
Yeah.
only for commercial purpose. uh, the fuel cell can store, the hydrogen can store for the commercial purpose, for like we are using the hydrogen cylinder, we need for experiment
Yes.
purpose, we need for some other purpose.
Mm.
Okay, maybe some medical purpose they are using. So for the commercial purpose, there is some fuel station available. But for the public uses, like for vehicle purpose, there is no uses at the moment in the China.
Okay, so thank you very much.
Okay, sir.
Any more questions or queries? Yes. Anyone has any query? Okay, it seems no one has any query. Then we proceed further. Thank you, sir. On behalf of organizing committee, I sincerely thank Dr. Santosh Kumar Verma, sir, for enlightening session on chemical engineering for green and sustainable future. The discussion on different types of hydrogen, supported by relevant case studies, provided valuable insight into sustainable energy solutions. The session was further enriched by the explanation of magnesium based solid state hydrogen storage and the associated project work, which opened new research perspectives for our participants. We are grateful to Dr. Santosh Kumar Verma sir for sharing his expertise and inspiring us towards innovation and sustainability. Thank you once again for your valuable contribution to this FDP, sir. Despite of the time zone gap, you spend lots of time for our FDP, sir. So thank you once again for your valuable session.
Thank you, madam. Thank you very much.
Yes, welcome,
Thank you
sir.
all of you for listening me.
Participants, we have to wait till our next speaker join shortly.
Okay, madam. I'm log out now.
Yes, sir. Yes, sir. You can.
Thank you, madam. Good night to all of you. It is 10:15 in China now.
Good night, sir.
Good night. Yeah.
Good evening, sir.
Good evening, madam.
Again, it is a pleasure to welcome back Dr. Vijyendra Kumar, sir, Head of Department at RIT Raipur, on the second day of our Atal Faculty Development Program. Yesterday's session on water conservation was highly informative and well appreciated by the participants. Today, Dr. Vijendra Kumar sir will continue with further insights on water audit, helping us strengthen our understanding and academic perspective. We are thankful for his continued association with this FTP. Now, over to you.
Thank you. My screen is visible to all of?
Yes, sir. It is
Okay,
visible.
thank you. Few things need to correct. Earlier, I was in RIT, Raipur Institute of Technology, as a head of the department in chemical engineering. But after June 2025, I left the job and I have started my own firm, that is Bharat Envirotech. So I am the founder and director of this company. So this is only possible with this heading, that is water audit. I have cleared this exam that is conducted by the CGWA, and that exam is very rigorous and very tough, because if we talk about the fee for this water audit, the fee of this water audit exam, that was 1 lakh rupees. So in the last year, only 13 people are qualified for this water audit exam, and one of them, I am this certified water auditor from the CGWA. I will also show the list of water auditors, like 1 minute, please. This is NoCap portal. NoCap portal is the portal of this Ministry of Jal Shakti. So we'll go down in this website and you can find the list of certified water auditor. So we'll click, then you can find the 1, 2, 3 up to number 46. So the 46th number is I am Dr. Vijyendra Kumar. So in India, only 46 water auditors are there. So this is the reason why I'm here to present this presentation, right? So I'm thankful to CGWA that he make me the capable to be to create a company or employ the peoples. And even in the couple of months, I have also worked with the various company. Like this is my website. You can also check. I work for the JHW, Balco, Nalco, Ultratech. Many industries I have worked. I have done. They are my clients. So there is very interesting topic. This topics not only give the information that the industry how can they conserve or save the water, but also give the skill that how you can do the audit in different industries. So maybe after learning this skill, they may can join the consultancy, right? So similar kind of event I am also doing with this NIT Raipur in upcoming event that will be held in the January 5 to 9. So with the collaboration with the NIT Raipur, I'm conducting this event, water auditing and management. And you can see also the speakers are very well designated, like from Bureau of Indian Standard, from NIT Raipur, from Balco, from Ultratech, from IIT Guwahati, and from CPCB, Dr. Amit Thakur, like various specific or designated persons are there for this course. So you can also join in upcoming events. I'll share this information. So why I'm sharing, because the topic is very important and you will be able to or capable to do this kind of similar thing what I'm doing, right? Now, see, as if we'll say what is audit, right? So see the what the CA does. CA does the auditing of money. So similar kind of things done by the water auditor. So in this water audit things, the auditor enters the streamline of water from where the industries are taking the water and how they are storing, how they are utilizing, how they are misusing, and how converting in the their sustainable process. So all kind of things includes in this auditing thing, right? But now in this today's session, we are just we have to discuss about the water audit, right? So in this session, we'll talk about this will fall under the which act or the history of the CGWA, how this is related or interconnected with the NGTs and some notification. So these things we will see in the upcoming slides. So the beginning or history of this CGWA, that is actually there is a number of relations in India. You can see in this previous decades, like in 1960s there was agriculture or green revolution, and in 1970s there were white revolution. So similar at the time of 1985, Mr. M.C. Mehta, he find that the water level is decreasing nearby their area. So he filed the PIL in Supreme Court. So after concerning with this Supreme Court in 1996, they directed to the government of India to form the authority for this regulation of government groundwater, right? So in 1997, CGWA has constituted this CGWA. CGWA is constituted in 14 January 1997 under Section 3A of Environment Protection Act 1986, right? And if we'll talk about the upcoming year, that 1919 to 205, CGWA creates some new guidelines and some charges or the rules and regulation for the abstracting the water from different categories or area. Like as I have earlier discussed in last class, there is three major area. where the CGW is concerning, like industries, infrastructure, and mining. These three areas are where they have to maintain the or they have to follow the rules and regulation for the abstracting the groundwater, right? And in 2006, the first major guideline for evaluation of proposal for groundwater abstraction were notified, introducing mandatory clearance for the industries. So before uh, without getting the NOC, the industries can't get the environment clearance. So that will be decided in the 2006. And in 2012, revised guideline emphasized strict control in overexploited area and critical area. We have earlier session we have discussed the classes of the area: overexploited area, critical area, and semi-critical area, or safe area. So accordingly, the guidelines again revised in 2015. CGWA introduced online application. So this online application, how can do by any industry or any new upcoming industry? I will show you. This is a NoCap portal, and the whoever want to apply for NOC, see the written the sentence is the NOC. So they can log in this portal and then apply for NOC, groundwater NOC. After that, they will be able to take the water from the groundwater, right? And if they extract water without NOC, so there may be a high penalty and charges. I will show you what are the charges. And in 2017, draft guidelines proposed strict norms for packaged drinking water units and industries in states area. And in 2020, notification again revised and updated groundwater regulation framework focusing on sustainable uses, recharge, and monitoring. And in the year of 2020, so what are the things, because we are in this year, so we have to know about the rules and regulation, updated rules and regulation as per the CGWA. So what are the guidelines they have updated into 2025? That is updated rule for obtaining to NOC for groundwater abstraction. That is earlier was no cap. I will show you. This is no cap, but now if anybody want to take NOC, they have to take NOC from the new website of this Ministry of Jal Shakti, that is Bhunir. This is the website Bhunir. So with this website, anybody can take the NOC from CGWA. The earlier was no cap. And the next amendment, accreditation policy of groundwater professional and consultants. So from the last 2 to 3 years, CGWA concerned with this specific focus on the uses of water, and they have formed some professionals and consultants to stick their policies, right? And public notices what issued on children falling into wells, and address change of CGW headquarters to House, New Delhi. So this is new changes for these children falling into wells. And hiring capacity building, CGW announced hiring of 11 professionals for application development and maintenance of its digital system. See, these are the history of this CGWA. This slide shows the sources of water. Everybody aware with the sources of water, right? There is a surface water, groundwater, rainwater, recycled water. There are a number of various sources. But why I'm discussing this? Because whenever we will talk about the audit, there is clear-cut focus, that is the abstraction of water from the borewell. We are bothering only for the borewell water. So CGW is directly concerned with the borewell water, right? Now, in this slide, we'll just see the general definition of water audit. So what is water audit? Actually, the water audit is a identification of water, or identifying the water, measuring, monitoring, and reducing the water consumption and wastewater generation by appropriate means, activities in industry or any organization. So where these things have written like industry or any organization, because there are three important categories. I have said that the industry, mining, and the infra. So that's why they have written the industry or organization, right? So in this water audit, actually this is a systematic process of objectively obtaining a water balance by measuring water flow from one point of water withdrawal or treatment through the distribution system. Means suppose anybody is abstracting the water from the borewell. Now in this audit, we observe where they are following the norms or policies or compliance or not. In this audit, the auditors studied, right? And in this method, quantifying water use in a simple or complex system to reduce water use and often save money on otherwise unnecessary water use. So these things not only save the water, but also save the water. We can say their efficiency or energy efficiency or water use efficiency or the financial issues are also, right? The need of water audit. What are the needs of water audit? Water shortage, high water consumption compared to the benchmark or similar industries. So high water consumption compared to benchmark or similar industries. So every industries have, as per the CPCB or CGWA, the different benchmarks. According to the benchmark, they have to produce their production. So you can see the different industries and their benchmark. You can see for sugar industries, the benchmark is around 1.5 to 2.2 cubic meter per ton of cane crush. Similarly, if you see for the pulp and paper industry, the benchmark as per the guidelines of CPCB, that is 75 to 100 cubic meter per ton of paper. Similarly, for textile, 100 to 150. For stainless industry, 3 to 5 cubic meter per ton. For thermal, 3 to 4. So similar different industries are there, but you can see the maximum usage of water you can find it then in pulp and paper and the textile, 75 to 100, or approx it will conclude the 75 to 150. The range is 75 to 150 cubic meter per ton of production, right? So this is the benchmark already decided by the CPCB and the CGWA. As per this guideline, industry have to produce their production, right? Have to do their production, and some other needs for resources efficiency, local regulation for discharge, compliance requirement, ESG, that is another burning trending topic, right? And increase water use and recycling, water efficient organization and future. So these are the points that shows the needs of water audit, right? Who should do water audit? So any industries abstracting the water more than 100 KLD, that will fall under the category of this water audit. They have to do the water audit, right? So the main criteria is 100 KLD. And these things is written once in 2 years. So that depends upon the category. Means that is suppose this, for industry. So in case of industry, once in a 3 year. For mining, once in a 2 year, and for infra, every year, once in every year. And the objective of this water audit, as per the CGW, so industry have to reduce the water audit up to the 20% in every 3 years, as per their category, right? So CGWA also published the SOP for water audit report. So earlier there were 7 stages to conduct the water audit, but now the CGWA published SOP. In the SOP there is 10 chapters. According to the 10 chapters, we have to follow their headings and subheadings, and accordingly we prepare the reports for CGWA for industries, right? And certified water auditor to carry out water audit. Obviously, only the certified water auditors is able to do the audit. Water audit report to be submitted on CGWA portal and presentation to be made to the expert appraisal committee. So that depends upon the different sets. It's not necessary to give the presentation, but this report is only submitted when the signing authority given the consent, like certified water auditor, and second one is the industrial head or environment head. After that, that report will be submitted to the CGWA portal. Now the advantages of water audit. So definitely if in terms of individual, in terms of government policies, in terms of industries, or in terms of conservation of water, there are various advantages of water, right? So these advantages, that how much water you are consuming in total, you can find out. You will also know the water you consume for different activities or process. So in this audit, there is balancing of water. So in that case, you can also find out the how much water you are using in different activities. Accordingly, you can plan for optimization, or remove the obsolete technologies, like the things, right? And you can also quantify the water wasting of water, right? And opportunity to identify water saving measures, also opportunity to identify reuse and recycle measures, and also optimize water use by improving water use efficiency. So by using new technologies, that we can once we quantify the water quanta, we can also by taking the advanced technique, we can also increase the efficiency. The same time, also save the energy, save treatment costs, and save the manpower cost, and also meet the ESG, SR requirements, and improve the compliance. If okay, 1 minute, I want to tell some rules regarding this extracting more than 100 KLD. If if any industry is extracting more than 100 water, so there is two category. So if any industry is abstracting below the 500, and if any industry abstracting the water above the 500. So what is the difference? So if any industries abstracting the water below the 500 Kelly, so there is no need to do the IAR, impact assessment report. They have not to do the impact assessment report. But any industries abstracting the water more than the 500 KLD, at that time they have to compliance the report with the IAR, impact assessment report. Then again, this IAR is categorized for the industrial purpose and for mining purpose, right? So if we talk about the for industrial purpose, we can say that the IER is associated with this directly. IER is associated with the only the groundwater modeling. But once we are, if mining industries are there and they are setting the more than 500 KLD, so in that case they have to prepare the HAR, hydrogeological impact assessment report. So that is very important point. Now we'll see the scope of water audit. When we conduct the water audit, or get the offer from any industries to for the conducting of water audit, they have different scope as per the as per their the state, how what are the things they are following. But clear-cut scopes are already defined by the CGW. That is, all processes, utilized areas where water is used or processed or treated or stored or consumed within the industry organization, or in township, that should be quantified. Next one is the pre-audit activities and conducting of water audit and post-audit. See, this is the overall brief of water audit, or main soul of water audit, this 4 part, right? So step by step, we'll see the things, what will happen in the pre-audit activities, and in the conduction of water audit, and after the post-water audit, right? So in the pre-audit activities, what will happen if suppose any industry offer to any auditors to please come and do the audit. So at that time, the auditor what does? So industry auditor does that, he send a questionnaire. He sent the questionnaire. In the questionnaire, then different questions are they have related with this industries, like their introduction of their industries, last 3 years of your abstraction of water, their rainwater harvested capacity, and their treatment technology, what are the treatment that you are using. Similar kind of various questions they have put it for the in the questionnaire. So once auditor gets this questionnaire, he prepared the draft report with this data, and and also relate the with the benchmark with the different industries. For example, if some industries are related to the same industries, so they have different benchmark, or some industries are steel industries and they have different benchmark, right? So after completion of this questionnaire, auditors that follow that confirm that when he will visit the industry, right? So what? So after the visiting, they again the next step over there. But before that, we just see the point. What are the points under this pre-audit activities? Know your client industry, as I have said that what kind of industries are there. Send a pre-audit questionnaire. Carry out desktop research about that sector. So before the visit the industry, auditors also asked the industry for about the NOC, as I have said that in groundwater NOC, CTEO, CTE, consent to establish, consent to operate, and various kind of documents I will show you. Various kind of documents he asked to industry for making this kind of report. Benchmark or peer industries, understand processes, systems, technologies, utilities. So these review past water audit reports, understand the reason as to what are the objectives of the water audit, talk to the sectorial expert, understanding the hydrogeology of this area or region, gather as much information as possible. So these things are done by the auditors before the visit of any industries, right? So that completely depend upon the questionnaire and the documents that related to this industry, right? So once this pre-audit completed, the auditor visit the industries, and after visiting the industry, there is a kick-off start with the meeting with this environment heads or their plant heads, and discussing about the questionnaire, what are they have data they have shared, whether they are meeting with the norms or not, or whether they have given the correct information or not, and some missing information. They are discussed with this plant persons, right? So point we'll discuss here, and then later on we'll see the different process through the figure, and we'll go the next upcoming slides, right? So kick off the meeting, discuss the audit plan and identify key industries, official staff, discuss resource person requirements, checklist of all data information required, walkthrough visit, monitoring and measurement, detailed process studied including utilities, water balance diagram, water saving options, action plan for implementation. So in this part, in the conduction of water report, the auditors visit the specifically the what we can say the bores in the groundwater honesty. There is a clear mention that the how much bores they are from the how much bore they are abstracting the water. So that first checked by the water auditor, and after checking this bore well, he also checked the flow meters, whether the flow meters is proper working or not, or the values they have given in the questionnaire for the quanta they are abstracting, that is matching with this or not. And after that, in the questionnaire, they also meet the whether they have constructed rainwater harvesting or any conservation technique or not, or they have, as they have said that in the meeting, for example, they said that there is STPs or TEPs and some different technologies they are using to treat the water. So the auditor visit the different areas in industry and just cross checking the things whether as per suppose if any industries have mentioned that they are abstracting the water from only 5 bore, but some industries are very clever. They are created the dig or created the bore number of bores as they have written, right? Because if you visit the industry is very the area of industry is very high, and even the some specific area in industry you can't go in that area, so you can find that. So at that time there is very difficult to find out the hidden bore wells, right? So that is very difficult. And some industries are also means like they are creating a pressure, like you just do the things, otherwise that will means what we can say the you will get the some threaten, like. So various kind of things we are observing, right? Now, all the things what in these slides are written, we will just see with this image, upcoming image, what we have done in the industries with these points. Once we have visit, we will discuss. We discuss with the whatever the questionnaire they have shared. We discuss with the industrial person. We also met with the plant head for this discussion, and whether they are the information they have shared, whether they are correct or not. Also check the different software, whether they are for the extracting the borewell water. For measuring the borewell water, there is a flow meter. So that flow meter is you can also find out the how much water is obtaining from the borewell. So that can be checked online through the their web portal, right? And this is the area where they have showing me like that this is the area where they are constructed the rainwater harvesting. So we also check whether they are they are doing annual maintenance or not, or just done the rainwater harvesting system and forget that. So just check also. And this is a piezometer. The industry also should install the piezometer. The piezometer is the instrument that through which anybody can check the depth of water or groundwater level, right? We are also checking we are checking the flow meter, whether this flow meter is working or not, properly working or not, or what are the data they have shared that is matching with that or not, right? So, and this is the instrument. This instrument is the ultrasonic flow meter, and we have installed this flow meter in the pipe, and this through this ultrasonic flow meter we check whatever the data they are sharing using their flow meter, that actually meeting or not. Because some industries are very clear, they have altered the alter the things of the flow meter and change the data. So that's why we also check the flow rate of the water through this ultrasonication flow meter. This is the image of flow meter installed by some industry. We also visit different their storage tank, their filtration tank. They are showing that, and they're explaining their process, how we are abstracting, how we are sending, or how we are treating the water. Right. This is a sewage treatment plant. So once they have shown their treatment plant, we also check whether this is only this is not this is only a building, or they are actually working or not. So we also check these things. You can see the different portion of this sewage treatment. So these are working. We also check this work of this STP. They are inlet and outlet quality of this STP. So as there is very important part of this water conservation and water audit, we are very concerned with this leakage of every industry. So in India, in even the abroad, huge means a number of industries are there. So as per observation, if any industries means if you'll take the average value of the leakage, so you can calculate that 10 to 20 kld of water is wasting only through this leakage. So we are very concerned with this, because if you will add for all the industries, the huge quantity of water we are wasting, right? So we are very bothered about this leakage, and also insist the industry to correct or fix this kind of things. And even we also report to the CGW this kind of things are happening in these industries, and we give the recommendation to fix this kind of mishappenings, right? This is coal mine. This is some industries we have earlier reached, and this is coal mines, Nalco. So in this Nalco, the difference between why I'm showing this audit in this mine area, because there's a difference in auditing in industries and coal mines. Because if we'll talk about the water audit in industries, so we'll talk about the abstraction of water only from this borewell, right? But we'll do the audit in the mining area. So at that time, you can find it the borewell as well as the once they are digging the earth for getting the cool. So at the time water releases from the earth, right? So that quanta water also countable in this. So that's why the audit for the industries and the mining area that differs. So the calculation for the industries and the mining, that will be different for the both the situation, right? So they are abstracting the water from the mines and collecting this water in this the pond. And after collecting this water in the pond, they are utilizing for the dust suppression or some uh, vehicle washing or some gardening or horticulture area, right? See, they are using this collected water for the also the construction of buildings. So there are various ways they can use for they can use this water. This is the horticulture area. They are utilizing the things. Conduct of water audit, data analysis and reports. So after a visit of the industries, whole industry, auditor prepare a report based on the data and their information and the analysis. So while the preparation data, there is two most important part, that is water balance 1 and the water balance 2. So what is the water balance 1? So water balance 1 is prepared once the auditor get the information from industries like from NOCs, NCT, CTO, and some questionnaire. So on that basis, he prepared the water balance 1. And after visiting and after analysis and after calculation and after implementation of uh, uh, means what we can say the uh, some recommendation, prepare the water balance 2. So the very sole or very important part of this water audit, water balance 1 and 2. So in this, after conduct visit, the points are the analyze data and information, break the process into sub-processes, analyze each utility separately. So the different industries had different utilities, like some industries have only the ME, multiple effective operator, some industries have RO only, some industries have some other treatment like only input neutralization tank, or some industry has only DP. So that depends upon the industry to industry and their water quality. Some industry have high TDS. So that depends upon their accordingly they prepare the or use their utility. And finalizing the water balance diagram without water saving options, finalize water saving options for utilities and process, finalize reuse and recycling options, finalize the water balance diagram using all water saving options are implemented, finalize action plan for implementation, consult client industries, obtain their acceptance. So this is very, I think, I would say, I would suggest the Ministry of Jal Shakti even that, because once we prepare the report, we are not capable to submit this report to CGWA without consulting the industries, even not only the consulting, even we take the signature of the industrial person. So sometimes what happens, few things are contradictory, or sometimes the industry is not agreed with our report, because we are preparing a report as per the data what we have observed, but sometimes industries want that just alter the things, because if you are not support, it's very difficult to run the plant. So that time very difficult for us also, because if some inspection agency is also coming to the industry after auditing, so that will be also difficult for us, right? So there is very difficult situation. And the post audit activities. So post audit activities, what is post audit activities? After audit, we just touch with the industries, like for utilization of recommendations, and after submission of report, sometimes CGWA accept that report, but sometimes he raised the query. To solve this query also, we kept this we are in the touch with the industries, and clarify if they face any issues concerning the data mismatch also, and send them a post audit questionnaire, inquire about water saving achieved. So these are the post audit activities, right? So the detailed activities during the audit we have already understood, and you can also read exactly what happened till now. They develop a water flow direction map, develop a water flow rate map, develop a water flow rate map with cost, examine the process closely and the technology being used, and collect production data, past, present, and future. Like last 3 years, we have collected and prepare a report. I will show you the report, how looks like the report. Assess the water requirement for each utility separately, a specific water consumption factors, as we have seen in previous class. Examine STP and ATP, whether they are properly working or not. Five water requirements or some other kind of utilities water requirement, rainwater harvesting opportunities, ZLDs, discharge. So this is the whole part of for the preparation of report. I will just show you the how it's look like the report. 1 minute, please. This is a water audit report I have done for the PUSPA agencies. That is actually very confidential, but I'll show you very in quick mode, so you can't find the some mishappens, right? So the PUSPA agencies private limited, we have done this report. You can see the different sections. I will show you. We have also put on our certificate in this report. So it's look like thesis of a master's or PhD, right? So I will just dragging the pages. You can see the reports, how it's look like. All the things you can find the data, photographs, all the things you can find it in this report from 0 to 100, right? See, you have seen, I think, the water balance diagram. This is the CGW NOC report. If anybody want to get the NOC, so this is the format of this NOC. So you can get this kind of NOC. You can see this number of borewell water is 2. So if you have applied for 2, and if you are abstracting the borewell water from the 3, so you get penalized, right? Yes. So this is the overall report of water audit. Now the documents to be referred once any auditor get the offer for audit. So they ask, as I have said, what are the documents need for this completion approval. That is the NOC, issued by the CGWA, CTE, consent to establish, CTO, consent to operate, EIA report. So these are the major documents. Without this document, report will be incomplete, and that is also a necessary part as per the SOP of CGWA. And the instruments required for conducting of the water audit. So basically, we just take the ultrasonic flow meter. Only with this, we just quantify or observe whether they are properly, their flow meters are working or not. So some other instruments you can see here. Some industries or some persons also they use this. So before in 2025, there were 7 stages to conduct the water audit. Team formulation, kickoff meeting, plant industry, wide end-to-end walkthrough survey, information, data collection based on record, logbook system, design and process, specification, monitoring, and O&M reports and records, and field measurement, interim report on water audit finding, and water saving action plan. So these were the previous one SOP, but now these are the 10 chapters based on the new CGWA SOP. This just 10 chapter we have to include in our report. So these 10 chapters, the headings of the 10 chapters are background and introduction, scope of work and the objectives, methodology of the studies, industry process study, assessment of present water uses including recycling, assessing use of technologies and best practices, wastewater treatment and discharge, data information analysis, interpretation, water conservation measures, feasibility and management plan, conclusion and recommendation, and the documents that I have that any auditors require, that is CTE, CTO, and all the things that will be attached in the last pages. So this is the brief of the report as per the CGWA NOC. And was one more important thing, I forgot the how the industries can estimate the quanta of water for as per the rainwater harvesting. So in every industry they have a rooftop, or said they have a road or paved area, they have a open land, they have a green belt. So after summing these or quantifying the by getting the information from the rainfall, how much millimeter of water uh, every month or throughout the average, they can get the information, and they have information of this with this area. So this is the fixed value for the coefficient, and after calculation, anybody or any industry can get the quanta of water, can conserve the water through the rainwater. Right. So this is the basic format to calculate the rainwater harvesting. And even we have a standard norms for calculating the water requirement for the green belt, that is 3 to 5 liter square per meter, right? And when we prepare the report, we have to give the some recommendations. So this recommendation formats look like that, like short-term recommendations, and medium-term recommendation, and long-term recommendation. So as per the industry's observation, we give them suggestions and recommendation to with their cost and break-even analysis, right? Now now again some few points remain to discuss. Like as we have know that any industries, they are accepting the more than 100 kV, they have to do the water audit, and the norms as per the CGWA, they have to reduce the water consumption at least 20% in the next 3 years, right? So these things we have discussed, but the same time we have to, as we had that, if some industries are violating the rules of this CGW, so what are the things may happen, we will see. Water abstraction or restoration charges have been incorporated in the guidelines and is levied based on the total quanta of water used, including wastage or misuse of water. The water charges are telescopic in nature, which encourage project proponents to reduce the use of groundwater, minimize wastage, misuse to pay less to the government. Environment compensation has been incorporated to restrict illegal extraction to bring the project proponent within the regulation framework and to reduce reckless use of water. So there is a different charges like EC, environment compensation, and some penalties, for abstracting the borewell water, some penalties for not install their flow meters, some penalties for their sharing the misinformation, right? We'll see in the upcoming slides. The penalties are levied for the non-installation and faulty digital flow meter with the telemetry system. So this is also, there is a penalty for the non-installation digital flow meter. And this is the data. A rupees 51.99 crore penalty has been realized by the CGWA from 24/9/2020 till 31/7/2023 from the project proponent working in 19 states and unitary regulated by the CGWA. So when we'll talk about the following states, so you can see the only 19 states that follow the CGWA. So this CGWA can't force the state to follow their rules. So some states like in South, they have their own rules and regulation. So from east, major states associated with this CGWA that are from east to west mostly. I will show you. And the average stage of groundwater abstraction for the country as a whole were out of 60.08% in 2022 estimation is compared with the 2017 estimation 16.30%. It is indicating the overall improvement in the groundwater regime. So he claimed, so CGW claiming that one after coming strictly in their what we can say, their impactful forces for through the young professional or auditors, they have conserved the water, or they have reduced the consumption of water. And as you can also see the data, the overexploited overexploited, the stage of groundwater extraction is more than 100%. Assessment unit in 2070 were 1186, that is 17.23% out of 6881. This is a unit. Yesterday's class we have discussed this. What is the unit? Assessment unit. Whereas in 2020 there were 1006 assessment unit, indicating an improved trend in groundwater scenario. So CGW is working towards this overexploitation of this groundwater, right? We will not discuss this ESG. That's a different huge topic. So we'll just we are leaving that things. And now we'll see. We have earlier discussed this GLD. So again, we'll see why there is again so important. We'll see here. GLD implies that the industries are not discharging any effluent either on the land or in water body or at any other place, recycling the same in the process entirely without releasing any effluent. And ME is the final treatment. So ME will multiple effective reduction. If some industries have high TDS, so they can utilize this through this equipment. They can treat the water and they utilize in the industry. The industry should engage an agriculture scientist or tie up with the agriculture. So in the last session, somebody can ask that HTP water we can use or not, right? So we have discussed that so they should have the take the permission from government, or they have to take the discussion with they have to do the discussion with the agriculture scientist or university. After analysis, they can utilize the HTP water or polluted water to the different area or horticulture or dust suppression, like the things, right? The industry should prepare a comprehensive irrigation management plan, which should include the following in consultation with the agriculture scientist or agriculture universities institute and submit to the SPCB or CPCB or PCCs. Boiler, how to optimize water reduce. Once when we visit the industry, we try to find out or figure out the how or where the industry can optimize the water or reduce the water. So any industry, suppose they are using boilers, so they have to do the regular water quality testing for their better efficiency, implementation in effective water treatment program, well-defined blow down schedule based on their boiler water analysis. Quality of feed water supply to the boiler is critical for long-term system performance. Proactive maintenance is key optimization boiler performance. So these are the points through which the efficiency can increase the boiler and reduce the consumption of water. Similarly, for cooling tower, there are few points for the same: maximizing the cycle of concentration, reduce blow down through the careful monitoring, install a conducting controller to the automatically control blow down, check the ratio of makeup flow to the blow down flow, make up the water treatment and cooling tower maintenance and upkeep. Another utilities are reverse osmosis, replace the filter regularly, replace membrane periodically, ensure proper air pressure in the tank. So different utilities have their own point through which they can optimize the uses of water, right? And the 7 ways to optimize the water. This is a basic or some like 7S or 5 kind of thing: eliminate, reduce, segregation, recycling, treatment, and reuse, through which industries can reduce or consumption of water. So eliminate industry, what can they eliminate? Conventional dyeing to waterless dyeing, reduce water efficient fixtures and nozzle for machine, segregation, high TDS and COD water from low TDS to and COD water, recycling, counter current washing, final rinse to be used as the initial rinse, treatment, physicochemical, biological, biochemical, and tertiary treatment, ZLD, reuse, process. Wastewater can be used for dust suppression in coal and ash handling, recharge, rainwater harvesting, and groundwater. So if any industry follow these 7 ways, so they can optimize or conserve the water. So as I have said that there are 17 industries are in the red category for as per the CGWA. They are using huge amount of water for their production. So they have some recommendation and the guidelines through which they can optimize the or reduction, or they can reduce the water. So industry wise we'll see what are the things. For example, if you see the food processing industry, they have to for conserving or for saving the water, they have to installation of ME, multiple effect evaporator, ultrafiltration RO system, or they can use after this they can utilize as a ZLD system. Replacement of existing old cooling tower with the new cooling tower to enhance effectiveness. Reusing the rejected bottling water or packaged drinking water. Reuse of ATP treated water in boiler by installation, UFR, ultrafiltration RO system. So these are the points through which in the food industry they can conserve. So similarly for the cement industry, implementation of heat recovery and a condensation system for clean quenching process, optimization the sewage wastewater recovery in STP, optimizing condensate recovery in boiler, replacement of existing dust suppression system, and out for new highly efficient dust suppression system. Again, this is the number of points. And for the pharmaceutical, so you can see the different points through which the industries can conserve the or use of water. Dairy industries, leather industries, distillery industries, paper industries, textile industries, and some other industries. This is general guidelines. Now, the benefits of combining. So, see, we are discussing about the water audit. If industries doing or compliance the things that is from the policy from the environment, that is energy audit, they have to do waste audit, environment audit, cleaner production audit, waste minimization. If you combine any industries, all this, so they will give the various benefits like enhancing operational efficiencies, identifying and mitigating the risk, improving data flow and integrity, strengthening the source security measures, future-proofing scalability, identifying growth opportunity, ensuring compliance with the industry. And so these are the benefits when they do all kind of audits. This is just image. You can see the water balance diagram. If suppose any industry is abstracting the 862 KLD from borewell, so that can be bifurcated with the different utilities or sections, how they are utilizing different with this water in different sections, like in the for the domestic section, for boiler section, for process or for cooling or for water. So this is the general or you can say the water balance diagram too. This is again water balance diagram. We can see different types of water balance and uh, enclosed here. Now, as we have discussed that about the penalties, right? So in the next slide, we'll talk about the different penalties and charges that is from the CGWA, right? So this thing, this is the history we have already discussed, and this is a map that is followed by the states followed the CGWA rules. The states are this Guwahati, Bihar, Jharkhand, Odisha, Madhya Pradesh, Chhattisgarh, Maharashtra, Gujarat, Rajasthan, Sikkim. So this highlighted part, the highlighted states are following the CGWA rule, and others they are in the highlighted with this white. They're not following the CGW. So that depends upon the state to state. CGW can't force to follow the rules and regulation as per the CGWA, right? Now, just we'll try to figure out where it's penalty and the charge is. See, the duration, as we have already shared the information, the duration of NOC for each type of user has been specified in the guidelines as 2, 3, and 5. So that depend upon the industry to industry, as we have seen. No new industries require groundwater except MSME permitted in the overexploited assessment unit. So if anybody want to open the new industry in overexploited zone, so they can't get the permission for abstracting the borewell, right? Even for only the relaxation for the MSME unit only, right? Some rules where we can see. This is the charges. You can see if any industry, you can see, suppose if we talk about the any industry, right? This is, I think, for mining. So if any industry is abstracting the water around, means less than 200 cubic meter per day, so he has to pay this as per rate of 1 rupees per cubic meter. If any industry is falling the category as semi critical region, so they have to pay 2 rupees per cubic meter. So similar kind of charges that is given by the CGWA for mining, for infra, or for industry, right? This is the easy environment clearance charges if somebody have not taken the permission or not given the even given the application before the 90 days of their NOC expire. So they have also give the environment compensation charges. That also depend upon the category which where they are, means if they are in safe category, they will give as per the 12 rupees per cubic meter. If they are in the semi-critical zone, so they will give the 24. So similar kind of charges are already given by the CGWA, right? And some penalties also given by the CGWA. You can see the non-installation or defunct digital water flow meter with telemetry. So they have to charges for their 2 lakh rupees. And the non-disclosure construction of additional groundwater abstraction structure, right, for their 2 lakh rupees. And if that is not defunct or abandoned for per structure, so there is a 1 lakh rupees. Reporting of freshwater zones as brackish or saline zone in application, for their penalties 2 lakh rupees. Non-installation of piezometer 2 lakh rupees. Non-installation of faulty DWR or telemetry 1 lakh rupees. Non-construction inadequate recharge structure 5 lakh rupees. Non-maintenance of recharge structure 2 lakh rupees. So these are the penalties that is from the CGWA. Injection of treated and untreated water. Yesterday one I got the question like STP water we can treat, we can utilize for charge or not. So you can see the rule, the injection of treated and untreated water. So if you are recharging through the untreated water, you can penalty, you can get the penalty of this amount, right? Non-submission of water level, water quality data around 50,000. Non-maintenance of logbook of daily withdrawal. Non-submission of groundwater absorption data. Non-submission of photograph of recharge structure. So in the report, that's why we have to also submit the different photographs of their structure or flow meters and all the things. Non-submission of self-compliance report. Construction of groundwater abstraction structure by unauthorized, unregistered drilling rigs. Non-registered of water supply tankers. Submission of false information undertaking. So you can see that there are various penalties given by the CGWA, but some rebates also given by the CGWA, like existing industries, infrastructure units, and mining projects which have installed constructed artificial recharge structure in compliance of the condition prescribed in the groundwater guidelines prevailing at the time of grant of NOC or its renewal shall be eligible for the rebate of 50% in the groundwater abstraction. So also supported by the government if you are following the compliance, right? And these things I have discussed. I think all projects extracting or proposing the extract water, groundwater in the excess of 100 in overexploited area, critical and semi-critical area, and in excess of 500 cubic meter per day in underlined by. Okay, this is some other part. Okay, and what other things remain to discuss for industry project? CWA. There are various things we can discuss, but that is not necessary. This is again one of the important parts. If somebody has installed the piezometer in their industry, so the piezometer shall be constructed at a minimum distance of 15 meters from the borewell. So if they have a borewell, so they have to maintain this 15 meter for installation of this piezometer. So I already said that the piezometer is a instrument through which we can measure the level of groundwater table, right? Also, all the things already decided by the CGWA, and there are various rules, some hidden, not hidden rules, some rules. Various rules are there for different industries and penalties and charges. Things required. This is the formula through which industry get. They have to give the compensation charges like groundwater consumption per day into ECR or compensation charges and the number of days and deterrence factor. That is different things. So this is the formula through which any industry can calculate their charges if they are abstracting the water without permission from the CGWA, right? So minimum they have to give the 1 lakh, but apart from 1 lakh they have to give the charges for the calculation as per their as per they are falling the which zone, safe, semi-critical, critical, or overexploited, right? Penalty provision. Okay, it's again repeated the things. Extension of NOC, installation, quanta. Okay, these things I have already shown that this is a CGWA no-cap portal where the industries person can get the NOC, but this is an older version. Now the app is Bhuneer app through which industry can get the NOC, right? And if somebody want to know the charges or somebody wants to know the they are falling in which category, safe or critical, so they can find this through this website. They have to mention some data and they can get the information whether they are falling in safe category, a safe zone or critical zone or semi-critical zone. This is the NOC. It's look like that, and the no-cap portal that is changed into the Bhuneer portal. This is the front page of this Bhuneer app. Glimpses of this advances feature of Bhuneer app. Okay, so I am concluding all the things. I'm finishing this lecture. So if anybody have some question or query, please ask.
Thank you, sir. Participants, if you have any queries, you can ask now. Yes, anyone has any query, questions? Participants, you can ask question. Any participants has any query?
So very good morning, sir. So very good evening.
Good evening.
So very clear, sir. Thank you, sir.
Thank you. Thank you. Thank you, Vijyendra.
So
So
I
in future,
think there is no query from anyone.
Good evening, sir.
okay, yes, ma'am.
Sir, I have
Good
one
evening.
doubt, sir. Suppose
Yes,
if
please.
we have an institution which is going to use around 50 kd of water within an urban limit. So, and if you want to treat and dispose 80% of the water within an urban area, what may be the solution, whether we have to go for a secondary use. If we are satisfied with a secondary use, what may be the next thing we can do with the treated water if it
So,
is within the urban area?
okay. So you just asking for the STP water, right?
Yes, sir. Yes, sir. Yes, sir.
See, for the utilization of this STP water, there is a clear-cut instruction to the government that you have to for STP and ETP, you have to consult with the universities and their expert, and after getting the actual result, accordingly, you can utilize that in for horticulture part or some your some the uses for in your household like car washing or some toilet flushing or other things. But as you have in the last class, you have asked for the recharging, so that is not permitted, right? So that things you can utilize only through the permission. And as you have said that suppose you are extracting the borewell water around 50 KLD, right? So
Yes, yes,
in that case, there is a rule. I don't know they have NOC or not. So they should have the NOC from CGWA. If they do not have, you can also inform them this because now the government is strict for their rules and regulation. They are sending the notice to different institutions like in this Raipur or Chhattisgarh. CGWA sent the notice to the IIM Raipur and some universities.
Okay. Okay, sir. Okay, sir. Thank you.
Okay, thank you.
Yes, any further questions? Participants, any questions? So here we conclude today's session. Thank you very much, sir. On behalf of the organizing committee, I extend my sincere gratitude to Dr. Vijyendra Kumar, sir, for delivering a highly informative and practice-oriented session on water audit. Sir clearly explained the stages and methodologies of water audit with the help of real-time industrial examples, making the sessions engaging and easy to understand. The discussion on data collection, analysis, preparation of audit reports, including CGWA prescribed audit for report formats, all these things include the valuable practical guidance to our participants. The session also covered the zero liquid discharge and highlighted various practical ways to reduce the water usage. Finally, sir also explained the concept of groundwater abstraction charges and their implications for industries, emphasizing the importance of compliance and jurisdiction of the use of groundwater resources. We sincerely appreciate Dr. Vijendra Kumar sir's time, expertise, and valuable contribution to this faculty development program. Thank you once again to all, and thank you participants for patiently listening the sessions. Thanks.
Thank you. Thank you. Thank you to all.